Now that we looked at markets, we're going to take a look at some pricing schemes, and the first one we'll look at is a very simple pricing scheme, and that involves pricing a single good at a single price. And let's begin by looking at total revenue first. And we know that when the price is too high, we won't sell any units, and therefore the total revenue is going to be zero. And then if the price, of course, is zero, we can sell a lot of units, but our total revenue is still zero. So somewhere in between these two endpoints, we will be maximizing revenue. And this happens when the marginal revenue is zero. And we looked at this earlier. The total revenue is not changing at all where that horizontal line is at the top of the total revenue curve. And this is the maximum of total revenue. But maximizing total revenue is not an objective of a firm. It's going to be profit maximizing. And therefore, we need to look at the total cost. So we're going to draw our total cost curve here. Keep in mind that the total cost curve that I've drawn here is simply an inversion of the cost curve we looked at when we looked at labor and price. And here we're looking at the wages and the quantity. So it's kind of an inverse of that one, looking at the short run costs. And we see that at this point here, at the origin, when the firm is selling nothing, then profit is zero. And anytime the total cost curve crosses the total revenue curve, profit is also zero, because at those points total revenue equals total cost. And we want to do is find where the greatest separation between these two lines, these two curves are. And that happens when you can draw parallel lines tangent to both the total cost curve and the total revenue curve, which happens right here. And this is the profit maximizing quantity at this point here. Here we've maximized the space between total revenue and total cost, which means we've maximized our profit. We can see that drawing a total profit curve, that's where it's maximized. It's not maximized where total revenue is maximized, and that's the big difference we want to look at. Notice also that we won't be selling beyond the maximum of total revenue. We looked at this already and saw that beyond QTR, that would be the points on the demand curve that are inelastic. So in this case here now, profit is total revenue minus total cost, and we maximize profit when marginal revenue is equal to marginal cost, and that's the change in total revenue due to a change in quantity, and the change in total cost divided by a change in quantity due to a change in quantity, and that's going to be the slope of these two lines. Where they're equal, we've maximized profit. So let's start with that simple pricing formula. First thing we want to look at is, profit is equal to total revenue minus total cost. We can draw that out a little more now. Say profit is equal to the price, which is some function of how much I'm selling. If I want to increase my output, I have to lower my price. If I decrease my output, I raise my price. So price is going to be some function of quantity times the quantity I sell minus cost, which is also some function of quantity. The more I sell, the higher my costs. So profit is going to be price times quantity minus cost, and both of those will be, the price and the cost are going to be a function of quantity. Now, if I wanted to find the maximum of my profit curve, I would simply take the derivative of profit divided by the change in profit divided by change in quantity and set that equal to zero. And so I do that by change in price divided by change in quantity times quantity plus price minus change in cost divided by change in quantity. And what this really saying is the marginal revenue is equal to marginal cost. Since we set it equal to zero, we can move marginal cost on the other side. And marginal cost is simply the change in total cost divided by change in quantity. Marginal revenue is the change in total revenue divided by change in quantity, and that's given on the left-hand side of the equation at this point. Now, I can multiply something by 1. It's an identity, so in this case here, I'm going to multiply the left side of that equation by price over price. And so that's going to be multiplied by 1. And next I'm going to distribute the denominator to a different point. I can still do that. It's still price over price. I've just moved the price in the denominator over 2 spots, so it's now quantity divided by price. Looking at the change in price divided by change in quantity times quantity over price should look familiar to you, and that's going to be the inverse of elasticity. Elasticity is the change in quantity divided by change in price times price over quantity. So this is the inverse, and I can now simply say price times 1 over the elasticity plus price is equal to marginal cost. Now I'm going to factor out P, and I can say P times 1 over N plus 1 is equal to marginal cost, and then divide both sides of the equation by 1 over elasticity plus 1. I've just reordered the 1 plus 1 over elasticity. And this is a simple pricing formula. That's what you really need to know. And the other things are just showing you from where it came. So price is equal to marginal cost divided by 1 plus 1 over elasticity. Remember, elasticity of demand is going to be a negative number here. So it will end up being a negative number. Now I can reorder this even further and come up with the following equation. This is price minus marginal cost divided by price is equal to minus 1 over the elasticity. Again, elasticity is a negative number, so the right side of the equation will be positive because a negative times a negative is positive. The left hand is the markup over marginal cost formula. And this will come in handy in a little bit, so you really need to know both of these equations. Price is equal to marginal cost divided by 1 plus 1 over elasticity, and then price minus marginal cost over price is equal to 1 minus elasticity. So question number 1, what is the profit maximizing price to charge if the marginal cost is $10 and elasticity is minus 1.2? Go ahead and take a minute to pause the video and try to figure that out. And now that you've had time to figure that out, price is equal to $10 divided by, minus 1 over 1.2. I've simply taken the negative sign in front of elasticity and moved it out. So it's 1 minus 1 over 1.2. And the profit maximizing price in this case is going to be $60. Now, what if elasticity is equal to minus 2? Again, pause the video and try to figure this one out. When we use minus 2, it's simply 1 over 1/2, and that's going to be doubling our marginal cost. So now price is equal to 10 divided by 1 minus 1/2, which is equal to $20. Notice that because elasticity is greater, that the price has to fall. And that makes perfect sense, and we'll see why in just a second. One thing we look at is what happens to price as elasticity becomes infinitely large. Okay, so it becomes larger, we see that price tends towards marginal cost, and when it's infinitely large, price equals marginal cost. In a perfectly competitive firm, we will see this happening. So here's a firm in perfect competition. When you have so many competitors in the market, price gets driven down to the marginal cost, and we see this in gas stations. Gas stations typically either earn zero profit or very, very little, sometimes even losing money on every gallon of gas sold, and that's because that market is so competitive they have to price at marginal cost, the actual cost they're charged for the gasoline they receive, and their money is made up when people go inside and buy drinks and cigarettes and whatever it is. Now, when we look at a price searcher market, that's a little different. It's not going to be equal to, price will not be equal to marginal cost. Price will be greater than marginal cost, as we saw in the monopoly market and the price searcher markets. So in a price searcher market, a firm chooses that quantity of output such that marginal revenue equals marginal cost, and then that's the price it's going to charge along its demand curve. So question number 2 at this, at the end of a holiday season, holiday goods become more price elastic. So if you think of Christmas items like Christmas trees and lights, after Christmas, fewer people want them, so the retailers will tend to mark them down and to try to get rid of them. So suppose the elasticity of demand for some good goes from minus 1.75 before the holiday to minus 2.5 afterwards. If the price was $7 before the holiday, and we're assuming that the firm was profit maximizing, how much should you price the item afterwards? Go ahead and pause the video and try to work this out. This has a little hitch to it. You're going to have to figure something out first before you can do this. So go ahead and pause the video and try to do that. All right, first thing you needed to do was find the marginal cost, because the marginal cost was not given. But you were given elasticity and you were given the price. So if you take the markup over marginal cost formula, $7 minus marginal cost divided by 7 is equal to 1 over minus 1 point, it's 1.75. Remember, it's a negative times a negative, so it's positive. And the marginal cost is $3. And once you have this, you can set price is equal to $3 divided by 1 minus 1 over minus 2.5, because again, the elasticity changed afterwards, and now the price would go to $5. So you went from $7 to $5 given the change in elasticity. This is the end of the simple pricing formula. We'll move on to more complex pricing formulas and price discrimination.